welcome to this video. This is Dr.M.MOORTHI, working as assistant professor in Department of Automobile Engineering, SNS College of Technology. So in this video, we are going to see about a different classification of heat exchanger. In that, we are going to see cell and tube heat exchanger. So before that, the heat exchanger is classified based on different category. So here we will see the based on the flow arrangement. Yes, we have discussed in the heat exchanger. The heat exchanger is working based on the transfer of temperature between the two fluid mediums. So that is either from heat transfer from hot fluid to cold fluid. So here we will here the heat exchanger is classified based on flow arrangement, where we have different types called parallel flow, counter flow, and cross flow. So here, see here. It is a co-current flow. So co-current flow means both fluids are flowing in the or enter in the same side and exit from the same side. So that is co-current flow. That is the fluids flow in same direction. So in the first diagram, the double pipe heat exchanger parallel flow, in which we have two tubes. That is a smaller tube is presented in the larger tube, where it carries one fluid in the larger, that is the outer surface of the inner tube carrying the another fluid. So here in the left side, both fluid, that is fluid 1 in and then fluid 2 in, that is both fluids inlet are in the same place. In the right side, we have the fluid 1 outlet and then fluid 2 outlet. So the both fluids outlet are in the same side. That is co-current flow type heat exchanger. The next one is counter current flow heat exchanger. So in which the fluids are entering in the opposite direction and same as it is exit in the opposite direction. So here the fluids flow in the opposite direction. See here, in the left side, we have fluid 1 inlet and the same we have fluid 2 outlet. So, one fluid is entering and then another one fluid is exit in the same side. In the right side, see here, the fluid 1 outlet and then fluid 2 inlet. So, this is a double pipe heat exchanger counter flow. So, this is the heat exchanger classification based on flow arrangement, that is parallel flow and counter flow. And then we have the term called dirt factor or fouling factor. So this factor will majorly affect the efficiency of the heat exchanger. So these are the unwanted particles presented in the surface of the heat exchanger. It's simply like as a unnecessary deposition in the surface. So it minimize or it decrease the heat transfer rate. So once we have lesser heat transfer rate, means it then automatically the heat exchanger will having the will face the lesser amount of heat transfer. Then automatically it lost its efficiency of heat exchanger. So see here, the deposition of any undesired material on heat transfer surfaces is called fouling, and then these heat transfer, so these fouling or the dirt material, unwanted material, will act as a resistance to heat transfer. So once it forms the layer in the surface of the heat exchanger, means automatically it will reduce the heat transfer from one medium to another medium. For example, if you transfer in the double pipe heat exchanger, a smaller tube is placed in the larger tube. So once the deposition is on the inner tube, means that is inner tube surface is surrounded by the deposition, means the once the heat transfer process is taking place, this deposition will minimize or will act as a resistance. That is the fluids inside the smaller tube is tends to it. If you take this as a hot fluid, means it will for the 100% perfect heat exchanger, it will transfer that is heat from the smaller tube to the surface of the outer surface of the inner tube, and then to the fluids it is surrounding or it is flowing in the outer surface of the smaller tube. Once the deposition is made on the surface, means what will happen automatically, it will reduce the heat transfer rate. So once the heat transfer rate is getting reduced, means automatically the heat exchanger will face the problems. So these type of resistance deposition called as falling or dirt. So these factors directly affect the heat exchanger efficiency. So if you want to get the proper or higher efficiency of heat transfer, means you have to remove all those deposition in the surface. For the heat transfer or yes heat transfer rate, the surface area will plays a major role in order to attain the maximum heat transfer efficiency. The second point, the falling increases the overall thermal resistance. Yes, if we want to transfer the temperature, means that is heat energy, these fallings will act as a resistance, and it increase the overall thermal resistance for the heat flow, and then lowers the overall heat transfer coefficient for heat exchanger. And then for new heat exchanger, we don't have see the dirt or some other unwanted particle in the surface. So for the new heat exchanger, we have falling factor as 0. And then it can be only be determined from experimental data on heat transfer coefficient of a fault exchanger and a clean exchanger of similar design operated at identical condition. If you want to get the exact performance of heat exchanger, means if you want to get the what is the real heat transfer coefficients, once we get the data, then automatically we will find out the exact the performance, that is the efficiency of the heat exchanger. Thank you.